set operations. So here we all know that set operations is nothing but we perform some standard mathematical set operations using the members of the set. We have several set operations like union, intersection, symmetric difference and set difference. So as we see that union is nothing but merger of two sets. For example, let us have an element S1 and S2 will appear in the union. Here we have seen the example that S1 is equal to set 4, 6, 9 and S2 is equal to set 1, 6, 8. So when we do the S1 dot union S2, so it will combine the elements in the S1 and S2 and give us a single set. For example, when we combine, it will combine in the ascending order like set 1, 4, 6, 8, 9. So you can use either union as a word or you can use the symbol, that is pipe symbol. So S1 pipe S2, which will print the union of set 1 and set 2. So again it will print set 1, 4, 6, 8, 9. This is all about union. Whenever we need to merge two sets, we use the union operation in the set. And next is nothing but intersection. So intersection is nothing but which will give the common elements, that is and any element which is in both S1 and S2 will appear in the intersection. So here we see the set S1 set is equal to 4, 6, 9 and S2 set 1, 6, 8. Here when we look into that, the 4 is not represented in both S1 and S2, whereas 6 is both in S1 and S2, whereas 9 is not there. Likewise 8 is not there. So when we give S1 dot intersection of S2, it will give the values that are in both S1 and S2. So 6 is in both S1 and S2, so it will give the set of 6. The intersection is also represented by the symbol ampersand. So S1 ampersand S2, which will give the intersection. So other than that, we can use S1 dot intersection update S2. That will also give the intersection value of 6. So only 6 is the value intersected here. If 1 is repeated, then it will give 1, 6. This is about intersection. Symmetric difference. The symmetric difference of two sets is the set of elements which are in one of either set but not in both. It will be in either any set but not in both. So when we give set 1, S1 is equal to set 4, 6, 9 and S2 is equal to set 1, 6, 8. When we give S1 dot symmetric difference of S2, it will give 8, 1, 4, 9 because 6 is repeated in both sets. So it will eliminate the repeated elements in the both sets and it will give the elements that are either in one of the set. So 1 is only in set 2, S2, 4 is only in S1, not in S2, and 9 is only in S1, not in S2, and 8 is only in S2, not in S1, whereas 6 is in S1 and S2. So it removes the 6 and it will give 1, 8, 4, 9. It is also represented by the caret symbol S1 of caret of S2, and it is also represented by S1 dot symmetric difference update S2. It will give the values like that. So this is about symmetric difference. What about the set difference? Python can also find set difference of S1 and S2, which is that the elements are in S1 but not in S2. Similarly, the elements will be in S1, but the element in S1 should not be in S2. So S1 dot difference of S2 is 9, 4. It will not give the S2 values, it give only the S1 values. Since the 6 is in S2, it will remove the 6 and give only 4 and 9. It will not consider about the 1 and 8 in S2. It will give the set difference, the difference of that particular set. So set 9, 4. So this can be difference by the hyphen. S1 hyphen S2, which gives the set difference of a particular set. So 9, 4. When we give S2 dot difference of S1, it will print 1, 8. So S1 dot difference update. So this is about set different. Multiple sets starting with Python 2.6, union, intersection and difference can work with multiple input by using set constructor. So S1 is set equal to 3, 6, 7, 9. S2 set is equal to 6, 7, 9, 10. S3 set is equal to 7, 9, 10, 11. When we do for the intersection S1, S2, S3, here 3 is not in all S2 and S3. 6 is in S2 and S3. No, it is not there. In S3, 7 is it in S1 and S2, S3, S9, it is in S2 and S3. We don't check about 10 and 11 because it is not in S1. So it will give the intersection about 9, 7. Finally, a frozen set. Frozen set is basically the same as set, except that it is immutable. Once it is created, its members cannot be changed because it's said to be a frozen. As we all know, frozen is nothing but it cannot be changed. Since they are immutable, they are also hashable, which means that the frozen sets can be used as a members in other sets as a dictionary keys. Frozen sets have the same function as normal sets, except none of the functions that change the content. For example, update, remove, pop, these will not be there available. Only these will be available. So fs equal to frozen set 2, 3, 4. S1 equal to set fs 4, 5, 6. So when we put the S1, set 4, frozen set 2, 3, 4 and 6, 5, because this 4 is common in that. So fs dot intersection of S1. So 4 is the only thing which is repeated in both. So it gives 4. Fs dot add 6, which cannot be done because it is immutable. So it is said to be the frozen set is immutable.